For this section, we're going to look at how we can compute probabilities for general normal distributions. And fundamentally, we have two ways we can think about this. We can either think about this in terms of z-scores, because remember, z-scores tell us about position relative to the mean and standard deviation, and they actually are the language we talk about when we're looking at the standard normal distribution. Or we can look at these in terms of the specific distribution that they're a part of. So I'll show you how to do both with this first one, and then later we'll see how to do more things in terms of the specific distribution we're looking at. Now here, notice that we have a mean of 22 and a standard deviation of 9. So a specific score of 4 hours would have a z-score of -2. So the behavior we're looking at here in terms of getting a probability for less than 4 hours per week is the same as getting a z-score less than -2. But when we put it into the calculator, we can handle it either way. So let's go into our normal CDF again, and we'll handle it in terms of that -2 first. So we have a lower boundary just trailing off to the side somewhere, and our upper boundary here is -2, where if we're looking in terms of the standard normal distribution, we'll keep the mean mu is 0, and the standard deviation sigma is 1. We run that, and we get about 2%, roughly. However, we could just as easily do this in terms of the specific distribution we have here, although I'll say that the more we do this with specific things, the more the door gets open to rounding error, which, like I said, is a major source of frustration in this section, but hopefully won't get in the way too much. Anyway, second CDF. We're still looking at a general value off in the tail, but now we're going up to 4, and we're understanding that with this distribution we have a mean of 22 and a standard deviation of 9. And if we run it on this instead of the z-score of -2, it doesn't actually change anything. So this is another point in favor of working with the calculator instead of the normal table. It's that the normal table is designed specifically for standard normal things. Here, we have a bit more leeway for the specificity of general things, because most things aren't standard normal. It's very rare, actually, to get something that follows the standard normal distribution. But either works, up to your patience with calculators and or tables. I'm not going to require you to use either at any point. It's a matter of what you're most comfortable with. On the other hand, let's say that we want to do something where we're finding an area between. Again, if we want to, we can convert everything that we work with to being in terms of z-scores and use standard normal distribution properties, use standard normal distribution probabilities. But really the only difference between a standard normal curve and a general normal curve is a matter of shape and, is a matter of scale and position. The shape, most importantly, is fundamentally the same, and the probabilities, up to rounding, are precisely the same. So in terms of what we're trying to look for here, it doesn't actually make a difference, depending on how we want to approach the problem anyway. But for this, what we can do is go into our normal CDF, put in the lower bound here of 22, the upper bound of 52, with a mean, in this case, of mu equals 43, and we'll get the standard deviation, sigma, in this case, is 12. Put all those in there, make it run, and as you can see, up to specificity we get the same answer. Where if you wanted to run that without those interface options, we wouldn't be changing all that much, but we might as well see how to do that at least once. What you would do is go into CDF, put in the right lower boundary, 22, comma the upper boundary, 52, comma the mean of 43, and then finally the standard deviation, which here is 12. And we get the same number, essentially. Finally, for our last example, we're going to see how you can do ones where you're going up and out instead. So here, again, we can talk about this in terms of the normal table, but there's really no reason to. What we're going to do is go in here, normal CDF, yet again, and now we have a lower boundary of 37, which we could convert to a z-score of negative 1.5, but, excuse me, negative 0.5. Gotta be careful. And then find a complement, or we could go directly in the calculator, make our upper boundary some large number. I'll use the standard 1e99 so you can see how to do that once, but really anything big works here. Just be aware of how big the values we're looking at in terms of our distribution are, but put something big in there. We have the same mean, same standard deviation, run it, and we get that our probability here is roughly the same, about 69.14, where you can use that to say something else about the overall amount of things in our distribution. Here, the amount of people in terms of the amount of time spent. But it's a specific thing for this specific distribution. It works similarly for other distributions with other values.